This is a resistance reduction question. The kind of question we'd like to see is how many amps are flowing out of that 100 volt source. So we want to determine the current that's in that 100 volt source. In trying to determine this, we will assess the circuit that's before us, and we'll look into our toolkit and find out just what kind of analysis techniques that we might have available to us. If we look at this circuit for just a moment, we'll find out that there are just resistors in this circuit, and the resistors are connected in a combination of series and parallel combinations. And so we would like to reduce the resistances by their series and parallel combinations to an equivalent resistance, and that will help us determine what the current from the 100 volt source is. Starting at the rightmost side, we'll see that R1, R2, and R3 are in series. And as we know, the equivalent resistance is equal to the sum of the three resistances, which in this case is equal to 30 ohms plus 4 ohms plus 16 ohms for a total of 50 ohms. So that rightmost branch, the branch on this side here, has a total equivalent resistance of 50 ohms. We'll show that by replacing the circuit with its equivalent resistance, a 50 ohm resistor. Now we're left with two resistors, RA and RB, and we'll note that those are in parallel. The top of RB is connected to the top of RA. The bottom of RB is connected to the bottom of RA, and so those two resistors are in parallel. We use our expression that says the equivalent resistance of two parallel combinations is RA times RB divided by RA plus RB. In this particular case, it's 75 multiplied by 50 divided by 125. A little math will tell us that this is 30 ohms. So there's an equivalent resistance in these two branches, which combine to give a 30 ohm resistance. So we will replace that combination with a 30 ohm resistor. Finally, we see that R1, R2, and R3 are all in series. And again, we find that the equivalent resistance of those three resistors is R1 plus R2 plus R3, which is equal to 5 ohms plus 30 ohms plus 15 ohms, which is a total of 50 ohms. So all of that equivalent resistance comes out to a single resistor of 50 ohms. 100 volts divided by 50 ohms means that the current here is 2 amps. And so we've solved for our current in our voltage source by using a method called resistance reduction. We have taken each of the resistors from our original circuit, and we've reduced them gradually to one single equivalent resistance, and from there we were able to determine the current that we're interested in.